Hello and welcome back to our Unit 3 notes for Algebra Geometry 2. We're on our second section, which is called Section 8.1 Day 1 Notes. And today we're going to be finding angles and angle measurements in polygons. And specifically today we're going to be finding the interior angles in polygons, which is all the angles that are inside a polygon, hence the name interior. So in these examples, I am going to fill out that blank real quick, but we're looking for the sum, which is if I were to add all of them up, what would they equal, of the interior angles, which means this angle here, this angle here, this angle here, this angle here, and this angle here. If I were to add up all 6 of those, what would I get? Now you'll notice in that picture they didn't give us anything, but there is a nice little theorem we have that says the sum of the measures of interior angles of a convex n-gon, meaning n is the number of sides, and the little formula we're going to use is n minus 2 times 180, n being the number of sides. So let's use this right away here. I'm going to count to see, for example 1, we want to find if I were to add up all 6 of those angles, what would I get? Well, the first thing is to find the number of sides. I got 1, I got 2, 3, 4, 5, and 6. A little side note is that the number of sides is also going to be the same number of angles every single time. So if I'm using n minus 2 times 180, n is the number of sides, which is 6. There's 6 of them. So I'm just going to put that in. I'm going to say 6 minus 2 times 180. Now PEMDAS comes into play here. We're going to do the parentheses first. 6 minus 2 is 4. And then 4 times 180, we just use a calculator real quick, and I've done this out ahead of time. 4 times 180, you can check my work, is 720. So if I add up all 6 of those angles here, 1, 2, 3, 4, 5, 6, for a hexagon, I would get 720 degrees for every hexagon. It's kind of crazy when you think about it. And we're going to keep using this here. I don't even need a picture. Last time I had a picture. This time we're not going to need it. It's the same direction. Sum of the measure of the interior angles of a convex 15-gon. So we're going to be using n minus 2 times 180. And if 15-gon, well, that means that n equals 15. 15 means number of sides in that 15-gon. So we're going to sub this in, 15 minus 2 times 180. And then we do PEMDAS, so 15 minus 2 is 13. And 13 times 180, again, I've done this ahead of time. You can check my work with a calculator, 2,340 degrees. So that is what all 15 angles in that 15-gon will have to add up and equal. So we're going to take this a step further. We're going to use this. So now we can find the total, right? Like any polygon ever. If they tell us the number of sides, we can figure out what the angles are going to add up to equal. Now we're going to take this, like I said, a step further. It says find the value of x in the diagram shown. So I see that x right here is one of the interior angles. I don't know what it is, but something that I do know is how to find what all of them will add up to equal. And the number of sides, we got 4 sides. So I'm going to find the total, the sum of the interior angles. So total here, I'm going to organize my work. I'm going to use n minus 2 times 180. And n is 4, so this would be 4 minus 2 times 180. 4 minus 2 is 2. And then 2 times 180 is 360. Now, if I were to add up all 4 angles in that quadrilateral there, it has to equal 360, which that is what we're going to do. We're going to say x plus 71 plus 135 plus 112 equals 360. And friends, that's an equation we're going to solve. Let's go ahead and do it right now because we're trying to find x. So we have like terms all over here. I'm going to add those up. 71 plus 135 plus 112. Calculator will help you out. X plus 318 equals 360. And I just added our like terms together. Now I'm going to take away 318 from both sides. I get this to cancel out and bring down my x equals 360 minus 318 is 42. which gets us our final answer. So another way we can use this very handy and useful theorem to solve problems. We're going to do it another time here, as you're going to see. And this one, I would like you to maybe try on your own here in 1 second. Now, they want us to find K and L. They give us these arcs. We don't know what they are, but we do know that they're the same. So we're going to do what we always do in algebra and math. Unknowns, we give them variables. So I'm going to call them both x. So we need to find x, and there's 5 sides here. So n equals 5. Go ahead and pause and see what you can come up with on your own. Now, hopefully you guys have paused and try this out. Here, I'm going to work it out with you and for you. So this is a pentagon. It's got 5 sides, 5 angles. I don't know what x is right now, but I do know that I can find out what all the angles equal. I can use our, again, very useful n minus 2 times 180 to find what all 5 have to add up to equal. N is 5, so we're going to do 5 minus 2 times 180. 5 minus 2 is 3. 3 times 180, and that is going to be 540. So the total, if I were to add up all 5 of those angles, they're 540. So we're going to add all those angles up. So the first angle I see is x, plus the angle L is x, and then plus angle M, which is 109, plus angle N, which is 105, plus angle J, which is 68. And if I add all those together, I have to get 540, which is what I got from our nice little theorem. Now I have a couple sets of like terms. X and x are like terms, and then 109, 105, and 68 are like terms. X plus x is just 2x. And if I do 109 plus 105 plus 68, I get 282. And I'll bring down the equals 540. Now I'm going to take away the 282 from both sides. So those will cancel out to get 2x equals 540 minus 282 is 258. Took me a second. And then divide by 2, divide by 2. We're going to get x by itself. X equals 129. So for here, we want the measure of angle L and K. Well, they are x. We can see that that's just x. That's what we want. So just to write it out quickly, measure of angle K equals 129 degrees, and the measure of angle L equals 129 degrees. And there we go. All right, so there's 2 examples of, using these totals to find what one angle is. We're going to work a little bit backwards here. So they say, what's weird is, instead of us finding the sum, they say the sum of the measures of the interior angles is 1,260. So they give us it. They want us to classify the polygon by the number of sides. So we need to find the number of sides. That is the main thing we need to do. So if we're going to classify it by the number of sides, we need to know, well, how many sides does it have? They tell us that the sum of the measures, equals 1,260 degrees. Well, we have an equation for this, or an expression for this. We've been using n minus 2 times 180, and they're telling us that that sum is equal to 1,260. Now notice, this is an equation. This is something that we can use to solve for n. I should probably use a different color here. To solve for n. And why is that important? Well, n is the number of sides. So this is an equation we can use to solve for n, which is the number of sides. Let's go ahead and do this. So to make this easier on us, it's n minus 2 times 180. The opposite of multiplication, what can undo it, is division. So I'm going to cancel out this 180 by dividing by 180. If I were to do this, again, those would cancel out. Because multiplication and division, they cancel out. I'm going to bring down and I'm going to drop the parentheses because we're not multiplying anymore. N minus 2 is left over. Drop down the equal sign. And 1,260 divided by 180, believe it or not, is just 7. Then we're going to add 2 to get n by itself. So that means n equals 9, which that is the number of sides. So we have 2 answers we could say. We could say it's a 9gon, because we can always say that. Or what we have, a better one, is nonagon. So another way we can use this handy little theorem to solve problems. And we got one more here. It says find the measure of each interior angle. That's a big word. Each interior angle, not the sum, but each, for a regular, another big word, dodecagon. So dodecagon is 12 sides. So that means n equals 12. And if we want to find what each angle, and remember regular means regular means it's going to be equal sides, and it means that it's equal angles. So all the angles will be the same. That's a big part of regular. Regular means it's going to be, all the angles are going to be the same. So we need to find one of them. Now I can't find one of them right off the bat, but I can find the sum. I can use n minus 2 times 180 to find what all 12 angles are going to equal. So let's do that. So instead of n, I'm going to put 12 because that's what n is in a dodecagon. And then 12 minus 2 is 10 times 180. And then 10 times 180, we just add a 0 at the end, 1,800 degrees. Now, if I want a regular each interior angle of a regular dodecagon, that means every angle will be the same. And there's a total of this many degrees. Well, I'm going to divide that by the number of angles, which would be 12, because it's a dodecagon, 12 sides, 12 angles. And if I do 1,800 divided by 12, use a calculator, we get 150 degrees. So there you are. You're going to have some questions to go along with it as well in your assignment. Please know if you have any questions specific to these notes or anything going on in Unit 3. Thank you for watching, and I'll talk to you guys later. Bye.